Hello stars, welcome to the new video. Last year I tried very hard to make a walkie-talkie. First I used 433 and 315 MHz transmitter and receiver modules, which were not very suitable because they had a lot of noise even in idle mode. A little later, I used NRF24L01 modules, which had better sound quality and a long range.
You can hear my voice from 500 meters away.
But I could never figure out the library and program written for this project. So why should I study more about the program and library of this project? To improve it, stay with me to explain more. The NRF24L01 module selects an empty channel to send and receive data so that the transmitter and receiver are synchronized. So far the project is working well and there are no problems. But as always, I would like to have a display and select the channel I want with a microswitch. I did this before, but I had to select the channel before connecting, and after connecting I was no longer able to change the channel. This means that we had to turn the device off and on to change the channel, which was not good at all. The reason for this is that the program is just listening at speed. Listening to the sender is done using a function that we do not have access to. As a result, the program never enters the main loop and no code can be written inside it. The good news is that this circuit has a microswitch that changes the state from receiver to transmitter, which is connected to the interrupt pin of the microcontroller. When the microcontroller is very busy processing something, only with the help of the interrupt function can the execution of the main program be temporarily stopped to execute another program. Apparently, this is what we have to do, so I wrote instructions that if the interrupt pin changes state, the communication channel changes. But this requires a side circuit. This is the new circuit diagram I designed. When we press a microswitch, the interrupt pin is connected to the ground along with another pin of the microcontroller and we enter the interrupt function. Now in the program, we can define what to do. One of the microswitches increases the channel number, the other decreases it, and the third microswitch sends the sound. I think it's better to prepare the circuit now and see if it works. First, I'll prepare the circuit without the display. The circuit doesn't work. I'm sure my breadboard is damaged. Let me design a PCB for our circuit. I'll design the PCB with Altium software and make the board with ACID, which I'm sure won't be good quality, but it's good for a temporary test. To produce high-quality PCBs, use PCBWay's services. This video is sponsored by PCBWay, a leading company in the production of various types of PCBs, including flex and the rigid flex PCBs, and even UV printing technology. They also offer CNC machining, 3D printing, sheet metal fabrication, and injection molding services. You can place your projects online and they ship worldwide within 24 hours. For more information, visit their website and Instagram page, which is listed in the description section below this video. Now both PCBs are ready. After installing the components on the circuit board, it worked fine.
1, 2, 3, 4. You with me, guys? Please don't forget to like this video. Thank you so much.
Now it's time to install the OLED display. After installing the microswitches, diodes, and capacitors, I realized that the display couldn't display the channel being used. The reason for this behavior is very simple. 63% of the microcontroller memory is full. This means that we cannot use this display because it has a heavy library. Well, I changed the program so that the 7-segment module shows us the channel used. Let's see if it works. Very cool. It requires a little delay in the program to set the channel correctly. But there is one more thing to note. I used 5 volts to power the module, but in this socket I have 3.3 volts. Let's see if the display works with 3.3 volts. Yes, it works, but the brightness is less. Now both circuits are ready. Let me connect the battery to see the result. When both circuits display 4 lines, it means the device is working on the default channel. Now what happens if I change the channel of the first circuit? The sound is not transmitted. I have to select channel 2 in the second circuit to transmit the sound again. Let me select another channel. For example, channel 18. Yes, our project works correctly. Just note that if the channel you want is empty, you can use that channel. In the next video, I will remove the microphone module and design an amplifier for the microphone, and maybe I will remove the Arduino from the circuit. But it depends on your support for this project. If the number of likes for this video is high, I will definitely make the next parts. So don't forget to like the video,